Hello, welcome to ECO-595, Business Research Methods. In this lecture, we will go over Chapter 20 in your textbook, Basic Data Analysis. So starting from this chapter, we will actually go over a few important statistical tools that are used to analyze data. There are typically two types of statistical analysis. One is called descriptive statistics, and the other one is called inferential statistics. So the techniques that we will learn in this chapter belongs to the first one, that is, we're gonna describe the data using basic tools, okay? And we call those descriptive statistics. Now, the nature of descriptive analysis is that we will actually just transform the raw data in a way to describe the basic characteristics of the data. And typically, we will be looking at central tendency, distribution, and variability. Now, in terms of central tendency, we are looking at usually the mean. There are situations we also care about the median and the mode. Now, we have different tools for different type of measurements. According to chapter 13, where we talk about different level of measurements, we typically use two types of statistical tools for data description. The first one belongs to the nominal and ordinal measurement level. Since for these two levels, we only look at categories. So we usually use frequency table, proportion, and mode to describe the data. And to further display the data, we usually use what we call a bar chart, or sometimes we use a pie chart that I will show you later. Now here's an example of beer sales. Actually, in this example, consumers are asked about where they usually purchase beer, okay? And the choices include drugstore, convenience store, grocery store, and other specialty, right? So based on the survey, it seems like convenience store is the winning star, right? So more people are purchasing beer through convenience store. The next one is grocery store, drugstore comes next, and specialty others is the least relatively. Okay, so this is a way to describe the data, right? And it's very useful because if you look at the raw data, right, the let's say 1,000 respondents to a survey question, you probably won't get any idea. But if you tabulate the data and present it using a bar chart, it is very clear that convenience store is the most frequent location, right? Now for interval and ratio data, we actually use a different tool. We will usually talk about the means, the standard deviation, and the variance. Sometimes we'll also talk about the range of the data. And to represent the data graphically, we use something called histogram. So here's an example of the histogram. It's actually quite similar to the bar chart we see here. Now the difference is usually for interval and ratio data, we see more bars right down here, and usually we don't see this much gap, okay, between the different categories, right? So what I want to do next is to look at a particular example and go over these different tools, show you how we use them, how we construct them, and when they are appropriate. So this example is about car sales. The Applewood Auto Group (AAG) sells a wide range of vehicles through its 4 dealerships. Ms. Catherine Ball, a member of the senior management team at AAG, is responsible for tracking and analyzing vehicle sales and the profitability of those vehicles. Catherine would like to summarize the profit earned on the vehicles sold with tables, charts, and graphs that she would review monthly. She wants to know the profit per vehicle sold, as well as the lowest and highest amount of profit. She's also interested in describing the demographics of the buyers, whether they are ages, how many vehicles have they previously purchased from one of the Apple dealerships, what type of vehicle did they purchase. Partial data for 180 customers are shown on the table on the right. So this is a typical example for a manager that needs to monitor the sales all the time. Every month, you will need to look at the trend, the summary in order to find out whether the business is on track, whether there's anything noticeably wrong, or whether there's any significant improvement in terms of the sales, right? Now, apparently, if you only look at the raw data, you don't get much information. Even if you look at this partial data right here, it's going everywhere. Locations are different, vehicle types are different. So it's better to summarize the data. Of course, we summarize data based on the level of measurement. The first tool we're going to talk about is called frequency table. Now, in the frequency table, we want to group data based on their classifications, and we want to count the frequency of the data falling in each category. Okay, so suppose Miss Ball wanted to summarize last month's sales by location. We can classify the vehicles sold last month according to their location using the following frequency table. So this is a very simple frequency table. Basically, you list the 4 locations and you also put the total number of cars sold in each location last month. That's a frequency table. Okay, it is also one type of tabulation we usually say. Now the next tool is called a bar chart. Actually, bar chart usually is used more often than the frequency table. The reason being the bar chart reflects the frequency table, first of all. Second, it is more direct. Visually, it is also more pleasant to look at because you can use different colors and you can tell right away that hey, in this location sold the most cars among the 4 dealerships. Okay, so that's a bar chart. Now, sometimes we also would like to know relative frequencies. That is, we want to know what is the percentage of the sales in each location. In that case, all we do is to really divide by the number of cars, using the number of cars divided by the total to get the relative frequency. Or you can say this is actually the percentage of cars sold in each location last month. Okay, so the relative frequency table gives us better idea as to what portion of cars are sold in each location instead of looking at the absolute numbers. Probably by looking at 40, you don't get much sense whether, oh, is this a large number? Is this a small number? But if you look at 22.2%, you know, oh, it's roughly 1/4 of the total sale. So for relative frequency, the best tool would be pie chart. A pie chart can be used to represent the percentage of car sales in each 4 locations. So here's an example of the pie chart. Basically, you just slice the pie into 4 pieces, and each piece will represent the percentage of the 4 locations. Of course, the size of the piece is proportional to the percentage. So that's a pie chart. And I believe it is not difficult. Actually, I believe most of you can do it already. But just in case you don't know how to construct bar chart and pie chart, here's a picture I took from my Excel. You basically just go to insert, and then under column, you would be able to find the bar chart here. Under pie, you will be able to find the pie chart. For the 2 graphs I have here, I basically chose the first one, the very basic one. And in Excel, you can do a lot of manipulation to whether you want to change the title, you want to add the title for the axis, you want to change the color, etc. There's a lot of manipulations you can do. All right. Well, the frequency table and the tabulation are useful when you have one category, one variable to look at. But sometimes, actually, we may want to look at the relationship among multiple categories. For that case, the cross-tabulation is the answer. Okay? So here's an example of the cross-tabulation. If we want to know the location and also the type of cards sold in each location, then we could create a cross-tabulation table. And here, as before, we list the 4 locations, then we further separate the card according to its types, and we count the number of cards that falls in each type in each location. For example, apparently here, for Kane, they sold 20 sedan last month and 21 SUVs last month. And by cross-tabulation, you can also find some patterns. At least, for example, for a few of the locations, including Kane, Honesta, and probably Sheffield somewhat, they sell more SUVs than sedan, not Sheffield. Actually, Kane and Honesta, they sell more SUVs than sedan, but for the other 2 locations, actually they sell more sedan. Okay, so from the cross-tabulation, we could find some patterns, and it's very useful when we want to. All right, let's now switch our discussion to the case of interval and ratio level measurement. Okay, for interval and ratio level measurements, we would use different tools to represent the data. Now here in this table, I have listed the 180 profits earned on the sales of vehicles by Applewood Auto Group. All right. There are 4 questions that we're interested. We want to find out the typical profit on each sale, the largest profit on the sale, the lowest profit on the sale, and around what value did the profit tends to cluster. Now, to answer these questions, actually, we could construct something called histogram to describe the distribution of the data. Once we have the histogram, we should have already found out the maximum, minimum, and also the mode, which is the highest frequency of the data. So typically, statistical software will allow us to find out the minimum and maximum with a function or a clickable button. In Excel, actually, we could do, in Excel, if you call the function, we could actually do equal to maximum, and you just highlight the data, and equal to minimum, highlight the data, then you will be able to find the maximum and the minimum among a bunch of numbers. In our case, the minimum is $294 and the maximum is $3,292. Okay. Now, in terms of the typical profit on each sale and the value, around what value the profits tend to cluster, this should be answered by something called histogram. To construct histogram, actually, we usually start with something called frequency distribution for quantitative data. Now, since we're looking at interval and ratio data, we look at the numbers. And we don't have the natural category to draw our frequency. And therefore, we need to define something called class. A class is basically an interval, okay? And we define different classes in the whole range of the data, then we're going to count the frequency within each class. And typically, we would pick 8 classes for a relative mid-sized data, right? And we also need to make sure that the 8 classes we have will cover the whole range of the data. That is, if you can recall, we have maximum of 3,292, minimum of 294. So our class intervals should cover these 2 numbers as well as the rest. The other thing we want to make sure is if we define class intervals, we need to make sure they are mutually exclusive. That is, any specific number cannot fall into 2 class intervals. All right. So for our example here, we pick the following 8 classes. As you can see, we tend to work with neat numbers, nice numbers. The first class interval is from 200 to 600. And by looking at the data, we found 8 profits falling in this class. The next one is 600 to 1000. And we found 11 profits falling into this. With the frequency table, we're going to be able to calculate the relative frequency. This is again to give us a rough idea about the percentage of sales falling in each class interval. With that, actually, if we produce a bar chart, that is what we want for histogram. It is essentially a bar chart, but for interval and ratio data, we call this a histogram. It basically led us to have a visual examination of the data. It also allows us to know the distribution of the data. All right. Now, actually, the distribution of data is very important in statistics, especially if you're gonna use advanced statistical tools to analyze the data. You definitely need to know the distribution of the data, and that comes from the histogram. For this data, we can tell roughly it follows such a what we call bell shape. I hope you've heard this term before. And that is usually used to kind of represent normal distribution, right? I could draw such a curve to kind of represent the pattern of the distribution. Okay. That's the histogram. And we can also tell that between 1800 and 2200, we have 45 cars sold with that amount of profit. So this is the amount that profits tends to cluster, right? We got the highest frequency. Now, what if we want to describe the relationship between two variables, right? We call that type of analysis bivariate analysis. The best graphical tool is a scatter diagram. In a scatter diagram, we usually put the dependent variable labeled as y along the y-axis, the independent variable along the x-axis. Okay, and of course, we usually need to differentiate between dependent and independent variables among the two variables we're interested. Here are a few examples, right? We have 3 scatter plots right here. Now, for the first one, it describes the relationship between aged buses and maintenance cost. As expected, the older the bus, the higher the cost, right? Just like when you buy a used car, you don't think you will not spend a penny to fix the car, right? Typically, a car, unless it's 1 or 2 years old, otherwise you probably have to spend at least a couple $100 or 20 or something dollars, some dollars to fix the car here and there. Okay, so apparently the scatter plot also shows that age and cost are related because we do see a roughly an upward trend. We call this positive related variable. We call these two variables are positive related. In comparison, if you look at this scatter plot, this is between auction price and odometer reading. If we're talking about used cars, apparently the price of the car depends on its mileage, right? And apparently the auction price will reflect that. As you can tell, they are negatively related. The higher the amount of odometer reading, the lower the price, right? So we call this negatively related. How about height and salary, right? That's an interesting question. Do tall people get paid more? Apparently, according to this scatter plot, it doesn't suggest any relationship, right? If you don't see an upward or downward trend, that means the two variables are not related. So typically, salary would not depend on height. I would expect salary to depend on education, experience, other factors, but not on height. Actually, there's one study that look at whether there's any relationship between salary and good looking. And the study did find evidence suggesting that there's positive relationship. So good looking people tend to earn slightly more in terms of salary. But that's just one study. It's not a um, what we would call proposition. It's not a how do I put it? A very confirmative truth about the relationship between salary and good looking. So we could use scatter plots to describe the relationship. Let's return to our Applewood auto group example. What if we want to look at the relationship between profit earned on the vehicle sale and the age of the purchaser? Basically, we're asking, are we earning more profit from elder people? Is it related to age? Okay, here's the scatter plot. Look at that. Do you see any pattern? Okay, so by looking at this scatter plot, we may have different opinion actually. Different people have different views. It's kind of hard to tell. A roughly examination, at least to me, shows that there's no relationship, but there might be slightly a upward trend, slightly. In this case, it's perfect for us to check it with regression analysis. So using regression analysis, we will be able to tell whether two variables are related or not. And that is our topic in the next lecture. We will be looking at simple linear regression, and then we'll be looking at multiple linear regression. All right. So this is the end of the chapter. I will see you next time.